So 6-4, properties of logs, and you're also going to solve logs. I have 3 new properties that I'm going to teach you that you can do with logs. And the point of these properties is because sometimes you guys are going to be given an equation and you're going to have like this log plus another log minus another log. And you actually cannot do that around the world conversion without just being one log. You also can't do solving properties without you guys having logs just isolated to one log. Okay, so we have to have properties that are allowed. I want to go over the first one, and it's called the product property of logs, okay? And here's the property. By the way, these are going to be considered the expanded form. The ones on the left side are going to be considered expanded. And then we are going to condense them, condense them down to one log. Because like I said, there's a lot of things you can't do with logs until they're condensed as one log. And you'll see what I mean in a minute. By the way, this works both ways. Your homework makes you practice both directions. You guys can write stuff expanded and you can write stuff condensed. We are going to use these properties again for those of you who I get to see in the Math 1010 to 1050 course next year. So those of you who I get to see in the college classes, we do these. And we do them a little, we use properties a little more complex. So a good foundation this year will support you guys next year. Okay? All right, here's an interesting property. Did you know when I have a log base b of something, and if it was in the expanded form in a sum with another log, see, notice if this was set equal to something, I wouldn't be able to convert it. It's not one log. Well, there is a property, and when you guys condense them, they become a product. So when I condense it to a log base b, I can times my x and my y, and I can bring them into one log and make them be multiplied. And it goes back the other direction. If I have 2 factors, they have to be factors, by the way, they can't be a sum or anything. If I have 2 factors in a log, they can be separated into a sum of 2 logs. Works both ways. Can I ask 2 people to show us something on the calculator? Can I ask 2 separate, you guys have them out. Do you guys mind doing 2 separate problems for me? So I'm gonna make you do the left one, and you're gonna plug in for me. Let me get a different color so that it's just kind of separate. Will you plug in a log, and I'm just gonna do a log base 10, so we don't have to change the base formula. I want you to plug in a log of 2, and then don't forget to press equal or close the parenthesis, and then add that with a log of 8. And I want you to tell me what your answer is. Now, if this property is true, what should it be equal to? Log of what?
16. Okay,
so Cora, type in log of 16, and you both are going to give me the decimal answer. Go ahead.
1.204.
Let's just stop there. 1.204. Cora, what did you get?
Which was the log 16?
Yeah.
1.204.
Same answer. So it just goes to show that you get the exact same answer whether you write them as sum of 2 logs or the condensed form. Okay? All right, this is going to work for a couple other properties too. If I happen to have a log base b of something and they are separated with a subtract sign, what do you think when condensed to one log the operation is now?
Division.
Division, because we said quotient. So x over y. And we technically could check it in our calculator again. You guys would be more than welcome to check it. If I said to you, hey, compare what maybe the log, I'm just going to stick to log of 8. Compare, I did a plus sign, sorry. We could compare in our calculator what the log of 8 minus a log of 2 is, and compare it with log of what, if this is supposedly true. What should this be equal to? 4. And you guys could tell me if they match. If you want to kind of test it, do it. Does anybody want to tell me what those results are? I'll let someone kind of work on it for a second. Go ahead.
0.602.
0.602 for the subtraction? Or did you do
4.
this one? Okay, well someone do the subtraction. log of 8 and then minus that by a log of 2. And do we get the same answer?
0.6 out of 2.
Perfect. See, so they match. Let's do our last property of these expanding and condensing properties. The last property is known as our power property. It's not jumping to my color I want. I'm not sure why. There it is. Okay. This one, as expanded, if I have a number out front, I'm going to use an R. And if I have a number out front of a log, I am technically allowed to, because when we are solving and converting and doing around the world, this number would make it impossible for me to do it. I would have to get rid of that R somehow. Well, you can either divide R over if there's a number, but if there's not a number to divide it to, you can also rewrite that R and put it as an exponent, hence the power property. So this R is technically moved up to the exponent. So this is known as the power property of logs. And again, if we were to kind of like test it to see if it's correct, if I, for instance, had a 2 times by, let's do a log, let's still do a log 10 to make it easy, log of 3, shouldn't that be equivalent to log of what? If I move the 2 up to an exponent on the 3, it should, bless you, it should be equivalent to a log of what? 3 squared. So someone tell me if you think 2 times log 3 ends up being equivalent to a log of 9. So who's willing to type in 2 times log of 3? Someone type that in for me. Anybody willing? Okay, would somebody else type in log of 9? And let's see what those 2 decimals are. Whoever has the first one, you can just let me know. What did you type in?
Oh, log of 9.
Okay, what's log of 9?
0.954.
0.954. Did anybody type in 2 times by a log of 3? And did you get the same answer? Did you? Okay, good. So it's just kind of proving to you guys these properties and that they're equivalent. Cool? Now these ones we already know. So these ones were new, and these ones we are learning today and doing in our homework. And then these ones down here, I'm going to switch colors maybe to a blue. These ones we are going to review because we already know them. But they're being used today, so it's good to review. We just learned last time, well, this one's kind of not review. We learned that if exponents, if I can rewrite bases to match, x can equal y. So what do you think would happen if I have a log of something equal to a log of something else? What do you think then? So if this is true, if I have a log equal to a log, my effort to clear this left log would also clear the right log. So we can just assume that what equals what?
X equals y.
Yep, x would equal y. Same reason why we had b to the x if it's a b equal to y. My effort to clear the b's would actually clear both of them, so we may as well save ourselves the time and just say, hey, x equals y. Okay? So this is a new property that if you guys can get 2 logs on each side, you guys could solve them. You may also possibly need to know the inverse property, which we already knew, we already did. We already learned, and this is the most important property to use because we use this everywhere. Didn't we learn that if a log can be, if I have a log equal to this, what was its equivalent form as an exponent? What was its inverse property? The b can be an exponent raised to what?
Y.
B raised to y is equal to x. These are equivalent properties. And this is something we used a ton last time on our properties lesson. Or sorry, 2 times ago. Last time was logs. So 6-2. This is, we're pretty much done with all the properties that you guys need to know. You guys actually have the skill set to solve everything we're going to do between today until 6-6. This is light. But we're going to scaffold you kind of like starting easier today, get a little more difficult next time, and then we're adding applied problems too. So we're going to kind of progressively learn how to solve everything. But you actually technically know everything now, okay, to handle the rest of the unit actually. Okay, but today's a little easier. So let's just start. Numbers 1 through 4 remind you of simplifying or switching back and forth. So let's just refresh your memory on that. What would this be? How would I rewrite this log as an exponent again? What's its equivalent form? 2 to the third should equal 8. That's its equivalent form. Good. What's this one as an equivalent form but as a log now?
Would it be
Log base 15.
3375?
3375 is inside, and what's
then
3 by
equals
some?
3.
Good. If you guys convert stuff properly, what was stuck in the log is now unstuck when it's an exponent. And then what was stuck in the exponent is now unstuck when it's back into a log. Okay? So you know you've done it right if you have essentially kind of reorganized those. Okay, that's numbers 1 through 4. Now the next section, 5 and on, is going to go through these properties up here I just taught you, and then we're going to solve on the back page, okay? So I'm gonna, does anybody need that slide still? Okay, I'll pause for a second. Good. And remember, you guys get to use these notes on your group test day, for those of you, especially my new ones. So I just want to make sure the more you have in notes, you get to contribute to your partnership a little bit more. So, all right, I'm going to move on. Is that okay? Okay. We're going to go ahead and try to condense these 3, but then we'll expand these 3, but 2 of them are your homework problems, so we get to give you a head start today. All right, how would you guys, so as we step back and use this, I kind of forgot to mention, if you guys ever have a minus, you can treat it like it's the exponent property, the power property, and move this up to the y and switch it to a plus. So there's actually 2 approaches on how to handle these problems. If you want all of them to just be pluses, move the negative number up, and then it lets you know what's in the denominator. But you don't have to do that either. So some people like to do 2 logs at a time and just wait for the 3rd one, or some people have a good idea of how to wrap their head around it and they jump right to the answer. So I'm okay with that. I'm going to do it in stages, and then you guys will start to get better at not doing it in stages. So how do these first 2 condense? With a log base 3, how do they condense since it's a sum of 2 logs? As 1 log, it's 2x. Good. And then this is either a minus or we chose to make it a negative. If you kept it as a minus, what should we do with that log? Put it in the denominator. Or if I had it as a plus and I go to condense these, this makes this be a 2 times x times y to the negative 1, which moves it to the denominator anyway. So was that step necessary? No. But if it was somebody who is, it makes them wrap their head around it a little bit better, sure. You guys are more than welcome to do these steps, or just realize that's the one that was in the denominator when I'm done. Okay? It's kind of cool that these properties are all equivalent. Let's go ahead and jump to this one. Now, we cannot have a number out front when you guys want to condense. You can't have a number out front when you want to convert the around the world. So what should we do first when we're condensing to make sure we don't have these numbers out front?
Put it out top.
Yep, that gets to be an exponent and that gets to be an exponent. So now that I have the ln or log, this is a 4 to the 1/2. We do expect you guys to not, oh my gosh, my brain. We do expect you guys to evaluate the numbers. So you need to make sure if a number can be simplified, you should. So what does that simplify to?
2.
Why did you know it was 2?
Because you have to, well, it's 2 and 2 is 4, so I could, because you split it in half.
Yeah, kind of. Rational exponents are also what?
Oh yeah.
Radicals.
Radicals.
So it's technically a square root 4, is what that is. You could have also realized that 2 squared is 4, and that being raised to a 1/2, those times, and it leaves me with a 2 to the 1. That's also another way to evaluate rational exponents, but a square root 4 is what the 4 to the 1/2 is. So this is technically an ln of 2, plus my ln of x squared. So when they come together as 1, what is that? 2 times x squared. Good job. Yeah, you guys are starting to see it. Okay. Tell me, what do you guys think this log base 2 is going to turn out to be like? Can we jump to it without all the different stages? What's going to be on top, and what do you think is going to be on bottom? X on top, and 4y on the bottom. Good. Now, if you didn't see it, which is okay if you didn't, and if you need to do it in stages, you can handle this a couple different ways. You could realize this is a division, and then you're dividing again. Or you could move this -1 up to make that a -1, and move this -1 up to make that a -1. So then when you condense it to a log base 2, you can say x times 4 to the -1 times y to the -1. Then you know which ones go on the bottom. The 4 and the y. So as long as you know you're doing allowed property, there's a couple different approaches you guys can take. Do we feel okay about the expanding or the condensing direction to 1 log? Do we feel okay? I promise you have 6 to practice on your assignment, so you guys will hopefully feel okay about that. I actually am choosing to do 2 from your assignment down here. So let's do 1 that is not from your assignment, just so you have it in your notes, and then let's go ahead and expand those other 2 on your homework, okay? All right, how should what I want you guys to do is look at every factor by itself. X squared is a factor, y is a factor. So this is going to be how many logs when it's expanded? Just 2. So when I first do the first expansion step, what is going to be, if this is a log x squared, what's going to separate that from the y?
2?
A minus.
Oh, the minus. Oh.
A minus, yeah. Log of y. Now it's not completely expanded, because I should do what with that?
Put it at the top.
I should bring it out. So I have a 2 times a log of x. Very good. And are we completely expanded? We are. So you're done. Okay, now this one gets to people because we have like a binomial inside. But what you want to view this as is this is a factor and it's stuck together. And then this is a factor and it's stuck. And then this is a separate factor. Okay? So what's going to happen on number 14, jump to your assignment, or you can put these in your notes. When I want to write this as separate logs, how many logs should I have?
3.
And what are they all going to be separated by?
Plus.
A plus sign. So log of what plus log of what plus log of what. Okay, let's do it all. So 1 log is going to be a
5 plus.
y plus 5. And a lot of people have a hard time wrapping their head around that because they feel like it can be expanded more, but it cannot. Okay, so only factors when it was 1 log can be separated into a sum. And that whole factor is in there. Okay? And then this is a y minus 3, and then this is a y. And this cannot go further. You would be done. That's as far as that one goes, and it's okay that it's just a binomial inside. So make sure the plus and the minus is what is separating the logs. That's what can condense and expand, not what is actually in the log. All right, let's try 16. Don't move the 2, 3, or the 8 yet, because the 2 is specific to the log with the x. The 3 is specific to the log with the y, and then the 8 is specific to the log with the w. So don't move those yet. And then ln's, don't let ln's scare you. They are treated just like other logs. So you do all the same properties, even with ln's. All right, how do you think I'm going to separate? How many ln's will I have, by the way? There's an x, there's a y, and there's a w. So how many? 3. So one ln is going to have x's, another ln is going to have y's, and another ln is going to have some w's. All right, how do I expand it?
2 of them are negative.
2 of them will be negative. And if you really wanted to, you could have done a little in-between step. You could have moved my y up, and you could have moved the w up, so that when you expand, you could have made them all a plus, but then when you move the -3 and the -8 out, it makes it a minus. You could have done it that way, if that helps you wrap your head around it. Or you could have just realized, hey, they're in the denominator, they're going to be a minus. And that's how easy it is. So this is a x squared, and this is going to be a minus, and then this is a y cubed, and then this is going to be a minus, and then this is a w to the 8. And then what can I do with those again? Move them down, move them down, move them down. And then you got it. So 2 ln of x, and then a minus 3 ln of y, and then a minus 8 ln of a w. I hope that that is an easy thing to wrap your head around. Okay, I have a quick, easy solving, and then one from your homework, and then I think you guys are ready to go. So let's try this one. Does anybody need this slide still to catch up? We all caught up? Perfect. I had a professor in college who didn't care, and it was just so hard to stay caught up because he would just erase a board before you even had all his notes done. And it was so, I'm very cognizant of that. Okay, quick reminder, we just learned this property today, right? If there are 2 logs on each side. And just a quick reminder, you check for extraneous solutions when solving is involved and when you have domain restrictions. We have domain restrictions with logs because didn't we learn that when we graph logs, I can't plug into all reals, I can't plug in negatives to logs, I can't plug in 0, right? We learned this. We learned this by saying, hey, if this is a log base b of something that's like a negative, b raised to what will give me a -2? Nothing, right? We learned that. We also learned that b raised to what will give me a 0, like this one, nothing. So if you try to log a negative and if you try to log a 0, you're going to find it doesn't work. So when your answer, when plugged in, gives you a log of a negative, that's called an extraneous solution. When your answer, when plugged in, gives you a log of a 0, that's called an extraneous solution. So get in the habit of kind of checking for extraneous. All right, this one's easy. I have a log equal to a log. So what can I technically just say?
3x plus 8 equals x squared plus
Yep,
x.
and then it's just a regular solve. Now we learned how to solve quadratics and polynomials back in Unit 3. So what do I do on this quadratic one? When there is a squared term and a linear term, what do we get all equal to? 0. Instead of isolating x, you have to compare it to 0 now. So let's move, are you guys okay? I keep x squared positive? So let's get everything on that side by minusing our 3x to this. And then it looks like I need to minus my 8 also. So do you guys know how to solve this polynomial, this quadratic?
Mm-hmm.
How do I solve quadratics from back in Unit 3?
-4 and 2.
Be more specific. We can do 2 methods. Factor or quadratic formula, and then you already factored it. So it looks like he's choosing factoring, and it can factor to 2 binomials. Because x is just an x squared, I can write x and x, right? Mm-hmm. And we got to decide what multiplies to -8 that adds up to a -2. Which factors work?
-4 and 2.
X minus 4 and then a x positive 2. So x minus 4 and an x plus 2. All right, what makes x minus 4 equal to 0 when x is 4? What makes x plus 2 0 when x is
-2?
good? Now, because I have a negative number, does it automatically mean it's extraneous, or do I have to plug it in to see if it's extraneous?
You plug it in.
You have to plug it in to see if it's extraneous. Just negative numbers doesn't mean it's extraneous, unless it's just a log of x. So when I go to plug it in, it should work. Plug in a 4 first. Log base 3, and when I plug in a 4, that's going to give me a 3 times 4, which is 12. 12 plus 8 will result in me having a log base 3 of 20. That's not extraneous. And as long as my right side has a 20, it's fine, right? So when I plug that in, I'm going to try the right side now. 4 squared is 16, and then 16 plus 4. Does that result in a log base 3 of 20? So these work, and it checks out, and it's fine. Now the -2 is the one I want to check, because that one could result weird. Could result in a weird combination of it. So let's plug in a -2. 3 times -2 is a -6, but I'm adding that to an 8. So does that still result in a positive inside my log?
Mm-hmm.
Yeah, so it's actually fine. It actually doesn't matter if it's a Negative
You
2.
can't have a negative 3.
Well, let's see. Well, not the base, but we're not plugging into the base. Is that what you mean?
I meant like you can't have a negative 3 or else the first one's going to be a negative.
Yeah. Yeah. Yes, so there is a domain restriction, but is this answer a domain restriction? No. Good. Plugging in a negative 2 would have given me a negative 2 squared, which is a 4, plus a negative 2, so it works. So as long as when it works and your result works, oops, if this didn't equal each other, it would not work, and if you tried to log a negative or a 0. But this one works, so this one checks out. Now that's the easy way when a log was already equal to a log. All right, let me do number 23 from your homework and show you something else, and then you're done. You know everything you can do to tackle the assignment. Does anybody need this slide a little longer? Okay, let's try 23. What do you guys notice is different about 23? And I actually want you to turn and talk for a moment on what would be your first step. So hurry, just quickly try your first step and tell me what happened. Okay, I want to see what your natural inclination would be and what's different about it. Do you mind if you hurry and ask around the room? You can be shy. Okay, no one's turning and talking. What do you guys try? So ultimately, I want you guys capable of looking at a problem and being like, what's my game plan, right? Good problem solvers think about what properties do I know, what can I start trying, okay? Did anybody try something on this? Give me right and wrong answers. I would love it, okay? Ty, do you want to tell me what you would try?
I tried first putting the minus into the y and the negative 2.
Did
So
you
it
put it
becomes-
into the y and the negative 2?
Yeah. I
Is
put
that
it
a property? Am I allowed to just turn those negative? Or was I supposed to turn what negative? The exponent.
Oh.
Yeah.
So would it be just...
So you can make that a negative 1 and turn that to a plus. That's fine. It doesn't necessarily make things, but that's a good first step. Don't distribute negatives into numbers. It would be an exponent. I'm so glad that you said that. Did anybody just think, I'm going to clear my logs? We can't as is, can we? No. What did you try?
I condensed it.
She noticed, I have a property. I know I can condense 2 logs. You guys know a property. You just learned it. Do not just drop logs because you don't have any property that lets you drop it in this form. The only way you can drop logs is if one log is equal to another log. That's the only scenario that I can drop logs. I don't have it as one log equal to a log yet. So you can't do that. So, but she realized, hey, I have a condensing property that I know. How did you condense it, Marie?
I did 2y plus 2 over y minus 2.
She made it a division, which Ty's approach would have been fine if he moved it to a negative and then realized it's in the denominator. Now, did anybody leave the right side as a log, or did anybody evaluate that from our lesson the other day? No one probably did. But I want to show you another approach if some of you guys realized that the right side would give me a number, which we'll do it after. How many of you know what the log base 4 of 4 is?
1.
It's a 1 because that log undoes it, so it's technically a 1. But what do I do now? Because I don't have a log equal to a log. So we'll get back to that. Because that's not, did I do a wrong property? No. So you are on the right track if you happen to do that. However, did I notice a log equal to log?
Mm-hmm.
So can I just take this
Mm-hmm.
and solve?
Yes.
Now we learned how to solve rational expressions last time, or rational equations. How do I solve something like this? I want to get rid of denominators. Do you remember?
Oh yeah, you y2 and then you times it into the 4.
Be more specific. Y2 what?
Y negative 2
Okay,
into the
this
4.
is in the denominator. So can I get rid of that factor y minus 2?
Mm-hmm.
Yeah.
And as long as I times it to what?
The 4.
As long as I do it to both sides, is my equation still balanced?
Mm-hmm.
Yes. So if I chose to times by an entire y minus 2, that means it has to be to both sides. And what do you guys think is easily forgotten on the right side?
Factor.
Yep, those two factors distributing through the factor, right? How many people would have just written 4 at y minus 2? But it's actually y for y minus what?
8.
8. That is my number one mistake, is people forget to distribute. We know how to do this. This ends up being 2y. I can minus 2y to both sides. I'm going to go ahead and add 8. How many of you got 10 is equal to 2y? So when I divide by 2, did we get y equals 5? Perfect. So that's your homework on that problem, number 23. We can take it and check it and make sure it's not extraneous and make sure that it works out. Now, I still don't want to leave you hanging here. We did nothing wrong by making this a log base 4 of 4, and this is actually setting us up for tomorrow. What can I do? What property do you know? If I need to get something unstuck,
Oh, you flip it, so that'd be 4 over 1.
4 to the 1 is equal to 2y plus 2 over y minus 2. What do you guys notice that matches identically?
The exact same.
The exact same thing. So as long as you're doing a lot of properties, you are fine, and you eventually circle back to the same place. Okay? So don't be thrown off to being like, oh, what if I realized that was a 1? Great. You now know how to solve when it's not 2 logs. Okay? But we'll get back to that. For right now, most of your homework has 2 logs today. Just condense first. The 10-minute bell did ring, so you do have just under 10 minutes, but I think you can knock out. I actually had 2 people turn in the assignment from 5th period, so feel free to try to knock it out. Maybe you guys can try to record stuff face-to-face. You do not have to submit stuff digitally. You guys can always come record face-to-face as soon as assignments are done. So, the time is yours.
Yeah.
Try to get it done. Let me hear you turn off the video.